Space, the final frontier. It's a vast, seemingly endless expanse that has fascinated humanity for centuries. From the twinkling stars that dot the night sky to the distant galaxies that stretch beyond our imagination, space holds countless mysteries and possibilities. It's a place where dreams of exploration and discovery come alive, where the boundaries of what we know are constantly pushed further and further. It's amazing, beautiful, and full of possibilities. The sight of a nebula with its vibrant colors and swirling gases, or the breathtaking view of Earth from space as the sun rises over the horizon, fills us with awe and wonder. Astronauts, working tirelessly in the vacuum of space, conducting experiments and building the future, remind us of the incredible potential that space exploration holds, but we're making it dangerous. As we send more and more missions into space, we leave behind a trail of debris. This space junk, consisting of defunct satellites, spent rocket stages, and fragments from collisions, is accumulating at an alarming rate. Each piece of debris, no matter how small, poses a significant threat to operational satellites and future missions. As we explore space, we leave junk behind: old satellites, used rocket parts, and bits from crashes. These remnants of our past missions drift aimlessly in orbit, colliding with each other and creating even more debris. The problem is compounded by the fact that this debris travels at incredibly high speeds, turning even the smallest fragment into a potential projectile. This junk flies around super fast and is a real danger to working satellites and future space trips. Imagine a tiny piece of metal, no larger than a paint chip, hurtling through space at speeds of up to 28,000 kilometers per hour. The impact of such a fragment on a satellite or spacecraft can be catastrophic, causing significant damage or even complete destruction. But there's a bigger, hidden danger: Kessler Syndrome. Named after NASA scientist Donald J. Kessler, this scenario describes a cascade of collisions in space, each generating more debris and increasing the likelihood of further collisions. It's a chain reaction that could render certain orbits unusable for generations. Imagine crashes in space, making more and more junk, causing even more crashes. The debris from one collision leads to another and another, creating a self-sustaining cycle of destruction. This runaway effect could result in a dense cloud of debris that envelops the Earth, making space travel and satellite operations extremely hazardous. That's Kessler Syndrome. So much junk in space that we can't explore it anymore. We can't ignore this. If left unchecked, the proliferation of space debris could severely limit our ability to access and utilize space. The very future of space exploration and the benefits it brings to humanity are at stake. We need to act now to protect our future in space. Scientists and engineers are already working on innovative solutions to mitigate the space debris problem. From advanced tracking systems that help avoid collisions to ambitious cleanup missions that aim to remove debris from orbit, these efforts are crucial. But it's not just about technology. International cooperation and responsible space practices are essential to ensure a sustainable future in space. The final frontier is too precious to be lost to the remnants of our past. Let's work together to keep it safe and accessible for generations to come. Kessler Syndrome, named after a NASA scientist called Donald J. Kessler, is a theoretical scenario in which the density of objects in low Earth orbit is high enough that collisions between objects could cause a cascade, where each collision generates space debris that increases the likelihood of further collisions. This concept was first proposed by Kessler in 1978, and it has since become a significant concern for space agencies and satellite operators around the world. Imagine a chain reaction of crashes in Earth's orbit. When two objects, such as satellites or pieces of space debris, collide at high speeds, they shatter into countless smaller fragments. These fragments then become new projectiles, each capable of causing further collisions. This self-sustaining cascade of collisions can lead to an exponential increase in space debris. When two things crash in space at high speed, they break into lots of tiny pieces. Each of these pieces, traveling at incredible velocities, can cause significant damage to other objects in orbit. The debris from a single collision can spread out and create a hazardous environment for other satellites, space stations, and even future space missions. Each piece becomes a new bullet, causing more crashes. These fragments, often no larger than a paint chip, can travel at speeds of up to 28,000 kilometers per hour. At such high velocities, even the smallest piece of debris can cause catastrophic damage to any object it strikes. This creates a vicious cycle where more debris leads to more collisions, which in turn generates even more debris. The more junk, the more crashes, and it gets worse and worse. As the amount of debris in orbit increases, the probability of collisions also rises. This can lead to a situation where certain orbits become so cluttered with debris that they are no longer usable. This not only poses a threat to current satellites and space missions, but also to the future of space exploration and utilization. If it gets really bad, we might not be able to use space for a very long time. The Kessler Syndrome represents a significant challenge for the sustainability of space activities. If left unchecked, the increasing amount of space debris could render certain orbits unusable for decades or even centuries. This would have profound implications for communication, navigation, weather forecasting, and many other services that rely on satellites. Therefore, it is crucial to develop strategies to mitigate the creation of new debris and to actively remove existing debris from orbit. It's hard to understand how much space junk there is, but the numbers are scary. We're tracking over 23,000 objects bigger than 10 centimeters. Millions of smaller bits are up there too, but we can't see them from Earth. This stuff flies around at up to 17,500 miles per hour, which is really dangerous for satellites. Even a small piece of junk can cause huge damage. If we don't do anything about Kessler Syndrome, bad things will happen. We use satellites for lots of things: phones, sat-navs, weather forecasts, and more. Going to the Moon or Mars might become too dangerous. If we lose our satellites, it will be really bad for the world. The worst-case scenario: so much junk that we're stuck on Earth and can't go to space. Section 5. Cleaning up our mess, challenges and solutions. In this section, we will explore the various challenges we face in cleaning up space debris and the innovative solutions being developed to tackle this growing problem. Cleaning up space junk is a big job, but we can do it. The sheer volume of debris orbiting our planet is staggering, with millions of pieces of junk, ranging from defunct satellites to tiny fragments from collisions, posing a threat to active satellites and space missions. We have some good ideas. Engineers and scientists around the world are collaborating to develop cutting-edge technologies and strategies to mitigate the risks associated with space debris. These efforts are crucial to ensuring the long-term sustainability of space activities. Active removal uses things like space nets, harpoons, and robot arms to grab big pieces of junk and pull them down to Earth. These methods are designed to target larger debris that poses the greatest risk of collision. Space nets can ensnare multiple pieces of debris, while harpoons can latch onto specific targets, and robotic arms can maneuver and capture objects with precision. Passive deorbiting uses things like sails and tethers to slow down junk so it falls back to Earth and burns up. These techniques are particularly useful for smaller debris that is difficult to capture with active removal methods. Sails increase the surface area of the debris, creating drag that slows it down, while tethers can generate forces that alter the debris orbit, causing it to re-enter the atmosphere and disintegrate. And we can design new spacecraft to come back down to Earth safely at the end of their lives. By incorporating deorbiting mechanisms into the design of new satellites and spacecraft, we can ensure that they do not contribute to the growing problem of space debris. This proactive approach involves planning for the end-of-life phase of space missions, making sure that spacecraft can safely re-enter the atmosphere and burn up, or be directed to a designated disposal orbit. International collaboration is key to addressing the space debris issue. Space agencies, governments, and private companies must work together to establish guidelines and best practices for debris mitigation and removal. By sharing knowledge and resources, we can develop more effective solutions and ensure the safety and sustainability of space operations for future generations. Public awareness and education are also important. By informing the public about the challenges and solutions related to space debris, we can foster a culture of responsibility and stewardship for our shared space environment. Educational programs and awareness campaigns can inspire the next generation of scientists, engineers, and policymakers to continue the work of keeping space clean and safe. The future of space exploration depends on our ability to manage and mitigate space debris. With continued innovation, collaboration, and education, we can overcome the challenges and create a cleaner, safer space environment for all. Let's work together to protect the final frontier and ensure that space remains a place of discovery and opportunity for generations to come. Section 6. A global effort, international cooperation for space sustainability. We need everyone to work together to fix the space junk problem. Countries need to make rules and agreements about space junk. We need to share information about where the junk is and work together to track it. And we need to work together to build new technology for cleaning up space. Section 7. Responsible innovation, designing for the future. We need to be careful when we explore space. That means making less junk by following strict rules and using new technology. We need to design all new spacecraft to come back down to Earth safely at the end of their lives. And we need to teach everyone about why keeping space clean is important. Section 8. The clock is ticking. A call to action. We're at an important moment. What we do now will decide the future of space travel. Governments, space agencies, and companies need to act now to stop Kessler Syndrome. This isn't someone else's problem. It's everyone's problem. Section 9. Safeguarding our future in space. If we want to keep exploring space, we need to fix the space junk problem. By working together, being innovative, and being careful, we can make sure space is there for everyone in the future. Let's work together to protect the beauty and wonder of space. Let's make sure we can keep exploring and discovering. Let's not trap ourselves on Earth because of all the junk we've made.